learning. We did 2 pounds with domain on Monday. And then we did a bunch of other stuff, evaluating functions, and stuff like that, term relations function. I want to continue with domain, because finding domain is important. A lot of the time when you're given a function, the domain is implied. Right? It's not specifically given to you, so being able to determine what the domain actually is pretty important. Also, as a reminder, when you come in, make sure you scan the QR code and check in. You can start putting the QR code up on the first slide as well if you come in early. If you're here on time, you can scan it there. So right. For this function, we have a denominator, right? Which means what's in the denominator can't be 0. That's factor. First thing you notice is that there is a common factor x, so factor that out. X squared plus 2x minus 24 is now a quadratic expression. You spent a lot of time in algebra working with quadratic expressions and quadratic equations. So you should know how to factor that. I think Common Core calls it trial and error. The method, I don't like that. Factors of 24, when subtracted, gives 2. 12 and 2. And higher one takes the plus. No, I'm sorry. 12 and 2 gives 10. What am I thinking? 6 and 4. I need more coffee. What was I thinking? 10. Oh dear. And they should be does not equal. The idea here is still the same. Right, before, you would just say set each one equal to 0 and solve, right? That's the 0 property. You take the product of real numbers and get 0, at least one of them has to be 0. A corollary of that is if you take the product of real numbers and it's not 0, then none of them can be 0. All right, so instead of ors, it's now ands. So we get x can't be 0, x can't be -6, and x can't be 4. There is no radical, right? So we don't have to worry about that. We're done. Set of all x such that x is not -6, 0, 4. That'd be the set builder notation. And that is definitely the easier way of writing this domain, rather than trying to write it as an interval. And you're going to have what? You're going to have 4 separate intervals you have to write as a union. That's our domain. Here we have a radical. No denominator. So we have to ask ourselves, what's the index?
2.
Index is 2, it's a square root. Is 2 even?
Yes.
That means what's inside the radical has to be non-negative. Right, x plus 5 is greater than or equal to 0. Linear inequality, right, real easy to solve. I think you may have done linear inequalities in Algebra 1. I think higher degree inequalities is Algebra 2. X has to be greater than or equal to negative 5. That would be set builder. I think in this case, the interval would be easier.
What's that line?
To infinity.
What's that line mean again after the first x?
Such that.
So it says x such that x.
Set of all x such that x is greater than or equal to negative 5. Again, that's actually implied to be the set of all real numbers x, because we're dealing with real valued functions. No denominator, you don't have to worry about that. Do have a radical. Index is once again even. What we're taking the square root of has to be non-negative. Now, in dealing with nonlinear inequalities, you have to start by finding what's called the breakpoints. Breakpoints are where the expression is equal to 0 and where the expression is undefined. Well, that expression is undefined nowhere. So we have to find where does it equal 0. Set the expression equal to 0, solve. Right, just like with quadratics and nonlinear expressions equaling 0, you have equal something, you have to get everything to one side and have 0 on the other. Right, so if that was an 8 over there instead of 0, I'd have to move the 8 over. Factors of 12, and I had to give 8, 6 and 2. And both take the same sign, negative. X is 2 or X is 8. Those are our 2 breakpoints. Now what you do is you set up test intervals. You take negative infinity to infinity and break it up at the breakpoints. So your first test interval would be negative infinity to 2. Oops, not 6. It should be 6. Why did I do 8? Then we go 2 to 6. Then we go 6 to infinity. We broke up all real numbers at the breakpoints. Look at each interval. Pick a point. It's called your test point. Plug it back into your expression to determine whether it's positive or negative. First one has the best one in it, 0. So you plug 0 back into x squared minus 8x plus 12. That's positive. And it's positive 12. 2 to 6, use 3. Plug in 3. Now it's easier to just use the factored form. 3 minus 2 is positive. 3 minus 6 is negative. Positive times negative is negative. Again, notice I don't care what the value is. I just care whether it's positive or negative. Then 6 to infinity, 10. You want to get positive times positive. Just positive. Now you look at your original inequality. Is it greater or less? It's greater. So you take your positive intervals. Can it equal 0? Yes. That means the endpoints are included. So the solution to the inequality is that. Which means that's your domain. Again, the interval notation here is probably the more convenient notation. If we were to write in set builder, it would be the set of all real numbers x, such that x is less than or equal to 2 and x is greater than or equal to 6. I shouldn't say and, it would be or. It can't be less than 2 and greater than 6.
Wait, so and is like a V and then
Or is the V.
or is the
And
V?
is caret. Right, so if you're familiar with union and intersection, it's the exact same, except it's pointed instead of curved, right? Union means or, one or the other, the elements in one or the other. Intersection means in both. or an and mean the same thing. Right, so that's why the symbols are very similar.
So basically, this is saying if x is less than 2 or it's greater than 6, that means it's all real numbers. But if it's in between, it doesn't count. It's not.
So not all. So it's all real numbers such that x is less than or equal to 2 or greater than or equal to 6, which means anything between 2 and 6 can't be in the domain because you'd have a negative in the under the radical.
Okay.
I could actually write that another way, but that involves a little bit more of set theory that you're not expected to know, so I won't use that notation.
But even if you did use the 2, you'd still get a negative though, right?
2 would be 0.
Because 2 minus 2, and then the other one would be 2 minus 6. Or does the other one?
Right, but 2 minus 2 is 0, and 0 times anything is 0.
Oh, shit.
So then it'd just be the square root of 0, which you're allowed to do. That's why you can include the 2. The same thing with 6. You get 0, which can be included. So here we have 2. We have a radical because it's the outside function. What's the index?
3.
Is that even or odd? No restriction. So we can ignore it. Now examine the denominator. What's the denominator?
X cubed minus 8. That's not, I mean,
That's why I ask. It's ultimately going to work out that we're going to look at the x cubed minus 8, but that's not what's actually in the denominator.
oh, x minus 8.
Isn't that under a radical? Denominator is the cubed root of x cubed minus 8. Because that radical applies to both numerator and denominator simultaneously.
X minus 2.
No, you cannot distribute radicals across addition and subtraction. You can do it across multiplication. So if that was 8x cubed, then it would be 2x. But because it's subtraction, you have to just leave it as the cube root of x cubed minus 8. So using that using the restriction, we know that the cube root of x cubed minus 8 can't be 0. But how do you undo a cube root? You cube both sides. So x cubed minus 8 can't be 0. There's no need to factor that. You can if you want. It'll just make it harder. X cubed cannot be 8. What's the cube root of 8?
2.
That means x can't be 2. Domain would be everything but 2. Now, is 2 the only 0 of x cubed minus 8?
No, because you have the negative as well, like your plus or minus.
No, because it's not. But you're right. It's not the only zero. There's two other zeros. But they're complex zeros. We'll be examining zeros of polynomials later this semester, including the complex. I'll be fair, probably just skip the complex because you're not going to need them. So again, being able to determine the domain is extremely important. As I said, most of the time, you're not going to be explicitly told what the domain of the function is. It'll be implicitly defined. So you'll just be given a function. And they'll be expected to know what the domain actually is. We're going to look at behavior of graphs next. Oops. So we'll go there. Three things in particular with behaviors of graph. You have average rate of change. Then you have increasing, decreasing. Incorporated with that would be mins and maxes, extrema. Then you have what's called concavity. And associated with concavity is inflection points. Right? Concavity is just how is the graph opening. Right, so parabola, concave up, which I think is convex. I think that's the formal name for it. Negative x squared, the upside down, would be concave down or just concave. I am going to ignore concavity. Because it is not intuitive where a graph changes concavity. Like if I just give you a graph, it is not easy to tell just from the graph where you're changing concavity. You would actually need techniques of calculus to do that analytically. I think there are certain graphing programs that might be able to do it. I'm actually not 100% sure on that. So I'll leave that for Calc 1. We will be looking at the increase and decreasing. Again, you're going to have to be given a graph. If I just give you a function without the graph, and I say find intervals of increase and decreasing without looking at a graph, you can't do it without calculus. So our study will be restricted to looking at a graph and determining extreme values and increasing, decreasing. Where is it increasing, where is it decreasing? Average rate of change. A rate of change, specifically, describes how an output changes relative to an input. Units of the rate of change are always the output units per the input units. One rate of change that you're familiar with. You use it every single day if you're driving. Your speed. In America, and only in America, it's miles per hour. Everywhere else, it's kilometers per hour, the correct measure. Actually, I would argue meters per second would be the actual correct measure. That's my physics talking now. Acceleration is change with respect to time, right? So it's using empirical units for the speed. It'd be miles per hour, either per hour or per second, depending on the time interval you're looking at, using seconds or hours. Average rate of change is the total change in the output divided by total change of the input. So delta y over delta x, change in y over change in x. F of x2 minus f of x1 over x2 minus x1. Oh. Well, x2 is, generally speaking, x1 plus some change, isn't it? Call that change h. That's the difference quotient. That's your physical interpretation of a difference quotient. Average rate of change. Which means the slope of a secant line also represents average rate of change. Now, this is a really fun thought experiment when you're first learning rates of change. Say you go on a road trip, and it takes you 60 minutes, 1 hour, to go 60 miles. What was your average speed during that trip?
You said 60 minutes or 1 hour?
Yep, so 60 miles in 60 minutes, so 60 miles in an hour.
1 mile per hour. 1 mile per hour.
60 miles an hour.
I thought you just said 60 miles.
Oh,
It's 60 miles per hour.
This is 60.
Yeah, it'd be 60 miles divided by the 1 hour. Right, 60 miles per hour. 46 minutes and 28 seconds into your trip, what was your speed?
60 miles.
60 miles per hour.
Not necessarily.
As long as your average was 60.
You don't know?
You have no idea. Just from that information, you have no idea. Or for all you know, maybe for 10 minutes, from 40 minutes to 50 minutes, you stopped at a convenience store, in which case your speed would have been 0 miles per hour. Right? At some points, maybe you're flying at 120 miles per hour. And you got pulled over. Now you're at 0, right? With that information alone, you don't know. That would be called your instantaneous rate of change. In which case, your instantaneous speed. That requires calculus. That is a derivative.
What about instantaneous acceleration?
Same thing. Instantaneous acceleration would be, what is your acceleration at that instant? That is a derivative. That requires calculus.
How would you even find that out?
You have to have a formula, or you can, if you're given a table, you extrapolate it from the table. But again, that's all techniques that require calculus. Or advanced statistics. So for our purposes, everything will be an average rate of change. Function f is said to be increasing on an open interval I if f is greater than f of a for every possible of a and b in I, such that b is greater than I. If you're looking at a graph, you read it from left to right. If your y values are getting larger over that interval, it's increasing. As read from left to right, that's what this says. Decreasing is the exact same definition with one change.
It's less than.
It's now f of b is less than f of a. That's the only change. Right, so again, if you're reading on a graph from left to right, if your y values are getting smaller, then it's decreasing on that interval. And if your y values don't change, so f of b equals f of a, then it's just constant. But those are boring. So graphical interpretation of what I just said. Extrema. Plural of extremum. Right? Yeah. Yeah. Extremum is the plural, extremum is the singular. Two types. You have local or relative, and you have global or absolute. So local, relative are the same thing. That terminology is used interchangeably. We say that a function has a local maximum at a point B if there is some open interval I containing B such that f of b is greater than or equal to f of x for every point in that interval. Right? In other words, you can find an open interval no matter how small where it is the largest value in that interval. And again, local minimum is defined identically with one change. It's now f of b is less than or equal to f of x. And the interpretation is, if you can find an open interval where it is the smallest value in that interval, then it's a local min. And again, no matter how small that interval is. This here would be a local maximum, right? Because there is an open interval where it's the largest value. And if I just go, say, negative 2.5 to negative 1.5, that's the largest value in that interval. So it's a max. It's a local max. And same argument down here. 1.5 to 2.5, that's the smallest value, so that's a local min. Can a function have more than one local maximum? Yes. Same thing with local min. You can have a function that has more than one local min.
Because it could just be like could it just keep going up and down and up and down? Like
That is a different idea.
like frequency.
Yeah, that's a different idea. I know what you're referring to.
So what would be an example of multiple minimums or maximums?
And will we have problems that have multiple?
Okay, so the two
There. and they're both local max.
Okay.
That could be like acceleration or speed, right?
It could be anything. And then same argument with local mins. The one you're referring to, the one you're trying to get at, is a periodic function that technically only has one max and min value. It just occurs an infinite number of times, but it's still just one value. Whereas the one that I just drew has two different values.
If there are going to be multiple local maxes and minimums, do they have to be separated by the y-axis?
No. So I could have just shifted that curve over so that both of them occur on one side. They're still both mins and max. They're still both local max. You could even have a local max that is smaller than the local min. That's a local max. That's a local min. Your max is smaller than the min. Right, that's why the word local or relative comes into play. Versus the global absolute extrema. Function has a global maximum at C if f of c is greater than or equal to f of x for all x in the domain of f. And the same definition when it comes to absolute minimum, except it's f of c is less than or equal to f of x. Can a function have more than one absolute max or absolute min? Oh, no. Does a function have to have an absolute max or absolute min?
No.
Nope. F of x equals x. What's the absolute minimum? There's none. No matter what value you give me, I can find one smaller than it. Same thing with maximum. No matter what value you give me, I can find something larger. By the way, that also doesn't have local extrema. Now, if a function has an absolute extrema, let's say it has an absolute max, that absolute max, is it also a local max?
Does it have to be?
Doesn't. Why wouldn't it have to be? So if it's an absolute maximum, can you find an open interval containing that point where it's the largest value? Yeah, you can. Which means it's a local.
With the largest point in an open,
In an open interval.
and that'd be the bottom.
And same thing with absolute min. If it's an absolute minimum, then it's also a minimum in some open interval around it, which is the definition of local.
Oh, so it's the same thing as a local term.
Well, it's not the same. Absolute is also local, but local is not necessarily absolute. Right? So every absolute extreme value is also a local extreme value. But the vice versa, the inverse, is the converse. The converse is not true. Right? So every relative is not an absolute. And so now we're just going to spend the rest, just about the rest of class today looking at graphs. And I am going to pull a point of privilege, because that's not actually a graph. That's a plot. Right, what you've been referring to as graphs throughout your math career is not a graph. They're plots. Graphs in mathematics is something different. It's a set of vertices and edges. So I'm just going to point that out. And probably still continue to refer to them as graphs. But if you hear me say plot, that's what I'm referring to. So look at the plot. What does it want us to do? It wants us to determine where the function is increasing and where the function is decreasing. Well, yeah, I guess what helped was actually on the right thing. So start with increasing.
-2, 0. And then 2, 0. Two, 0. So wouldn't it be from 2, 0 to 4, 2?
Right, so what's the interval? And so in this case, those are not ordered pairs, they're intervals.
Okay.
So you go from -2 to 0 increasing, and then again from 2 to 4 along the x-axis. That's all we're looking at. Decreasing. Right, it's going down from -4 to 2, or -2 rather, and again from 0 to 2. That's all. That's all there is to that problem. are we increasing?
Negative 1, 0. U negative 1, 2.
I agree, negative 1 to 0.
1 to 3. 0, 2. Wait, I don't even understand really like the question 1, like the increasing one. Like, how do you know? Because like I know you start from negative 1, 0, but like I don't know.
Well, so again, you're confusing intervals and ordered pairs again. So look here. What does it mean to be increasing?
Going up.
Your y values are getting larger, right?
Yeah.
Y values are getting larger here.
Yeah.
Negative 1 to 0. You only look at the x coordinates. So from negative 1 to 0, your y values are getting larger. So that's the interval of increasing. It's also increasing here, right?
So negative 1, 0. Or no, just 1, 0. 0 to 3? 1, 30.
1 to 3.
Okay.
Right, again, you're only looking at the x-axis when you're dealing with intervals. So all you care about is that x-coordinate. 1 to 3. What about decreasing?
Negative 3, negative 1.
Negative 3 to negative 1.
And then 0 to 1.
And then 0 to 1. Imagine if the exam was just a bunch of these types of questions.
And it is, right?
That'd be nice. Yeah, no, it's not going to happen. May get 1 or 2. And those will probably only be worth a few points. Imagine I just gave you 100 questions, 1 point each, just a bunch of these graphs. Determine where it's increasing, where it's decreasing. I think I'd be fired. You made it too easy. So determine where it's increasing, where it's decreasing. Start with increasing.
X. X. 1. X. 0. Negative X.
What do the arrows on the ends mean?
It's continuous.
So read that from left to right, and again, remember, it's never ending.
Negative infinity 0.
I agree with the negative infinity.
To infinity?
Yep, to infinity. Right, it doesn't stop increasing at 0, continues to increase, right?
Yeah, I was just thinking that point.
Well, in other words, that's increasing everywhere. Which means it's decreasing nowhere. So I'll just represent that as the empty set. It's actually supposed to be a 0 with a 1. Be careful, because there is a Greek letter that looks very similar. That's the Greek letter phi.
What's the difference?
That's a 0 with a slash through it. That's an actual letter. That's why I said you have to be careful with the notation. The phi, I think, is supposed. The slash is not as slanted. Right, the empty set is definitely more of a slant through the middle. So that's why you have to be careful with the notation.
same thing.
So where is this increasing?
Nowhere.
Negative infinity
Negatives
to infinity.
Infinity to infinity.
I agree with the to infinity.
1.
From infinity to infinity?
So it's definitely increasing to infinity.
1 to.
But what's the starting point? Not 1.
0.
0. Notice it's never crossing the y-axis here. The graph isn't defined for less than 0. And then decreasing, again, nowhere. Empty set. Where would it be increasing here?
Negative pi over 2 to pi over 2.
Anywhere else? Where's it decreasing?
Negative pi. Negative pi over 2.
Anywhere else?
Pi over 2. Pi.
We'll be studying that function towards the end of the semester. That's the sine function. One of my favorite functions.
Sine like SIN.
Well, the way I said it'd be SINE, I'd spell it out. What about here? Again, this function we'll be studying towards the end.
Negative pi 0.
Which one? Is that increasing or decreasing? You said what?
Increasing negative pi 0.
Anywhere else?
0 to 0.
0 to what?
0 to 0.
That's a single point, so it can't be increasing at a single point.
0 to 1. Negative pi over 2. 0.
That's included in the negative pi to 0. Yeah, that's all. That's the only place that's increasing. Decreasing.
0 to negative pi over 2.
There we go. Yeah, 0 to pi is decreasing.
Oh, so you just skip the ones in the middle? Yeah.
Well, I mean, didn't really, did we?
Not really, or like you just don't write them down.
The endpoints are never included.
Okay.
Again, that would be reasons of calculus. You learn that in calculus. So if I look, if I go back to here, just to show you concavity, this is concave up, this is concave down. And I think the inflection point is actually the origin in this case. But again, it's not really intuitive where it would switch without calculus, which is why I'm ignoring it. Right, this has 2 places of concave up
And that's at the
and 1 concave down.
concave up would be.
Right, so again, if I remember my calculus correctly, concave up is this interval and this interval. Concave down is that interval. Now, generally speaking, concavity switches kind of in the middle. Not always, but generally speaking. Where are we increasing?
2 to 3.
Anywhere else?
No.
Where are we decreasing?
-1 to 1.
Anywhere else?
-1 to 1/3.
That's included in the -1 to 1. Now, notice here we do have intervals where it's constant.
That would be -3 to -1. And 1 to 2.
It'd be constant over those two intervals. Oh, you had to do that, didn't you? I say it's a slightly skewed dipper. It's my astronomy nerd coming out.
-3 to -2.
-3 to what?
-2.
Anywhere else?
0 to 2.
Anywhere else?
No.
Where are we decreasing?
2 to 3.
Anywhere else?
No.
Which means we're going to have an interval of constant, right?
-2.
So I'll just write it out. And where's the constant? -2 to what?
0.
Yeah, so that's it for increasing, decreasing. Determining extrema.
-2, 0.
Where they occur and what the value is. Where the extrema occurs is the x-coordinate. The value of the extremum is the y-coordinate. That's the function value. You could also write an ordered pair as where it occurs as well.
That's what I was trying to do before. So it would be like -2, 0, 0, 3, and then 2, 0.
But be more specific than that. Yes, all three of those points are extrema. What kind of extrema?
Oh,
So remember, we have. I'm only going to write max and min. Generally speaking, in math, when we write max or min, we are referring to relative.
so the max would be 0, 3.
So the max occurs at.
Oh, you have to write that?
I'm just writing it to show the difference. So it occurs. So there are two ways. I can either say it occurs at x equals 0, or I can just write the ordered pair 0, 3. Either one of those. Unless I specify, like I may say, where does it occur? Write your answers in ordered pair.
Okay, this
Then
is
you'd
like,
write out 0, 3.
we'd have like this type of question on like a test or quiz or something?
And like I said, I'd say, as an ordered pair. Or I could specify the x value. The value is 3. Min. Again, I'm just going to write occurs. You don't have to. I just want to specify the difference.
-2, 0.
It occurs at x equals -2 and x equals 2. At -2, the minimum value is what?
0,
At 2, the minimum value is what?
0.
Are any of these absolute? Which one?
0, 3.
All of them? 0, 3.
There is an absolute.
Oh, -2, 0 and 2, 0 because
So the absolute minimum is 0, and it occurs twice.
and we don't know the maximum.
There is no absolute maximum. We know that there's not, because there's hours on either end, which means either end is going to keep going up to infinity. So in this case, there is an absolute minimum, it's 0, but there is no absolute maximum.
But what if the arrows were to signify that it was only going to go up to 3? And then 3?
Then they wouldn't be hours.
Oh.
It would continue. They would represent it some other way. All right, so again, let's start with the maximum. Are there maximum? Where?
2, 0, 2.
And the value is 2. Are there minimum?
Occurs at x -1 and x1. And then
First minimum value is what?
0,
Second minimum value.
0.
Same argument. We do have an absolute minimum, but no absolute maximum. Correction. Extrema is singular. Extremum is plural. Because maximum would be plural. Maximum is this is why man invented the search engine. Yeah, so extrema is plural. Extremum is singular. Yeah, that's right, because the maximum is singular. Maxima would be plural. So extrema is the plural form of extremum. Okay, so this is the sine function. They don't represent the arrows the right way. I'm going to go with this as actually a sine function.
It creates a negative pi over 2,
What does?
the minimum, and then with a value of -1. And then the max is the pi over 2. That creates that. The maximum.
I'm going to say how that's drawn. That's not the sine function. Right, assuming that's not the sine function, there's no global extrema. If that is the sine function, there is global. Both would be global. They just occur an infinite number of times. Right, this would be a case where it actually keeps up that pattern, but we typically would not represent with arrows. We'd stop it and then just put dots out to show that it's continuing on forever. What about here?
Maximum is at 0. Occurs
And what is the value?
0.
Oh, we don't know. I guess we could say 1.
Yeah,
That's like 1, right?
I'm going to say looks like 1. It's not actually labeled, so I can't say for certain that it is.
But it basically.
It looks like 1. Right? Remember, you can't assume it's drawn to scale.
So if you put a trick question on the test like that and we put 1, we would be wrong.
If you say for certain it's 1, yeah, that's wrong. You have to say, like, it appears from the graph to be 1. Or again, just do what a lot of people call the squiggly equals. That's the approximation symbol.
The minimum occurs at x equals negative pi with a minimum of -1. And then x equals pi with a minimum of -1.
Again, I actually technically should say x appears to be 0 too. I can't say for certain that it's 0. Because it's not drawn to scale. That dot could be ever so slightly off the axis. That could be like x equals 10 to the minus 9.
Can you also put less than or equal to 1, approximately less than or equal to 1?
No, because that covers a whole range of values. And also because it's not drawn to scale, I don't actually know that. I know for certain it's less than pi over 2. And I know for certain it's greater than negative pi over 2. Outside of that, I don't know for certain. I'm pretty certain the intention here was that that point is 0, 1. So I think that's just an oversight on wherever I got that from, wherever I got that graph from. Pretty sure it's just an oversight.
And you post the slides, right?
These will probably be up right after class when we sit down in the adjunct office.
Okay.
Video might take longer today. Because I somehow didn't bring my SD converter so I could run the video. Must have fallen out of my bag at home. So I won't be able to do that till I get home tonight. Which means videos probably won't go up till tomorrow. But we'll see. If I can't find it, then I have to order another one, which means they won't go up till the weekend.
What's gonna come first? Our first quiz or first test?
Quiz.
And when is that? Do you know?
It's every 3 weeks. So meeting 6, whenever that is. Actually, I think it's not this coming Monday, it's the following Monday. I already have it written. It's set to go up, I just don't remember the dates. Max. So maxima.
We have 1
Definitely agree at x equals 1.
with the maximum 4
Any others?
and 3. That's not enough. That's not enough.
Based on that drawing, I'd say no, that point is definitely not a maximum.
Oh, because it's not fully in the middle.
Again, that's probably an oversight.
Yeah, but like, what if you accidentally just put it a little bit to the left?
Because there is another max that occurs.
We could just say somewhere close to 3.
Probably occurs right there.
So it's like 3.1.
That's what I'm going to go with. Maybe 3.1. And the actual value itself,
3.
it's going to be larger than 3. I'm going to say maybe
3.1.
that looks more like a 3.01 or something. Because it's not quite as further up as it is to the right. So I don't know. That looks good. Again, I'm pretty sure that's an oversight on the publisher. They probably intended for that point to be 3.3, the maximum, but I would argue it's definitely not based on that.
The minimum occurs at x equals 2. But a minimum of 2. And at x equals 5 with a minimum of 1.
Were we supposed to label the global maximum and minimum for that last one? Because
You don't have to, because it's just saying where do the extrema occur, so you don't actually have to specify. Only if the prompt tells you to, would you then have to go, what, so if I could ask, list the extrema and state whether it's global or relative.
or 0. And then with a maximum 2. And then x equals 4 with a maximum of 4.
What about the minimum? The minimum.
So minimum at 1 occurs at 1.
And you said the value is
1. And then minimum at 5 occurs at 0.
at 5, not occurs at 0.
With a minimum.
Minimum is 0. The value is 0.
These are the quiz, or these are the like type of questions on our homework. I haven't looked at the homework.
There might be some that look like this. I think there's also some on there that give you the equation and you have to use a graphing utility. I think there's some with graphs on there as well. Maxima.
Occurs at 0 with a maximum of 3.
3. Any others?
At x equals 3.
And this, I would agree, is definitely equals. If you look closely, it's clearly going down.
And then with a maximum of 4.
What about minima?
Occurs at x equals 1.
I agree.
That's 1. And it occurs at x equals 4. That's 3.
I agree. And there are absolute here. Absolute max is 4. Absolute min would be 1. Maxima.
Occurs at x equals 2.
No, right? That's not right. It's an open circle. Right?
It's open, so yeah, that's not a max.
So then we wouldn't have one.
In this case, there are no maxima.
And then the minimum would be at x equals 0 with a minimum of 1.
Any others?
No.
I agree. Remember, open circle means the point is not included. It's a hole. Maxima.
X equals negative 1. It's 1.
X equals 2.
Does that mean that arrow is going up straight?
The max is 3.
So would it also be
And then infinity maybe.
whatever line that's on?
No.
Or down?
No, because it's never touching that line. And even if it was,
No, but just because it's going up like straight, we know where the x. No.
Are you saying like you know where the x is?
Like you know where the x is.
Since
So like it's gonna be
right
on.
there.
right, but it's never going to touch that actual value. It's going to keep getting closer to that X, that line.
Oh, I
but
thought
never
that meant
touches
it. I thought that meant it was going straight up that line. Like, I thought the arrow, I meant like the,
Yeah, so this, well, it's not really quote unquote going straight up. It's going to keep
okay.
kind of get closer and closer and closer and closer without ever actually hitting that line. Although even if it did hit that line and then went up as a straight line, what's the value? What's the maximum value?
Infinity still.
Which is not a value. So that still wouldn't be a max. It would only count if it ended at some really large value.
The minimum would be occur at x equals 0 at the minimum of 0. And x equals 3 from minimum of 2.
If I agree.
X equals -1. It's 3.
Agree?
And then x equals 2.
Agree? And what about minimum?
X 0
0.
and 2.
Any others?
No.
I agree. And again, same argument. It's going down. It's never going to hit that line. Plus, there's no actual smallest value. It never actually hits a minimum value there. Oh, this one's weird.
The max would be -2 with a max of 2. And
Max of 2.
a -2 on the one book.
Any other maxima?
No.
What about minima?
X equals 4, value 1.
Right, and this is one of those cases where your local maximum value is smaller than your local minimum value. Maxima here.
Occurs at x3 with a maximum of 1.
X -1. What value?
That would be a minimum though, right?
Yeah, for minimum, I thought.
Are there any other extrema? I agree. Right here, the local maximum happen to be the same. And in both of these cases, there was no absolute, right, because of the holes. Right, so increasing, decreasing, extrema, fairly straightforward. Again, you're going to have to use a graph to determine them. You won't be able to do it algebraically or analytically until you study calculus. That is something we do cover in Calc 1. Average rate of change. There are a few ways to represent it. The way that I typically do it
Change in 1 over change in
is delta F sub average to represent an average change in F. And that would be F of the final point, right? Minus F of the initial. over x final minus x initial. What is f of 2? Well, actually, let me actually just do it. So there's f of 2. That would be f of 0, right? And what is 2 minus 0? That's a real tough one. Oh boy. It's like a A in level 400 math course. It was really difficult. Here's why I wrote it out this way, actually. Notice that the 4's cancel out. You're just left with negative 2 times 2 squared, which is what?
1. Wait, you said
Negative 2 times 2 squared. Right, because these 4's will drop out.
negative 4.
And then that is just 0 here. So 2 squared is what? Times negative 2. And then negative 8 over 2. Average rate of change is negative 4. Right, you could also just evaluate what f of 2 is, which is negative 4. F of 0 is 4, so you wind up with negative 4 minus 4, negative 8. Another way I could represent this is actually with a bar over it. Right. Whenever you put a bar over something, it generally means average. Right? So x bar would be average of x. So if you do delta f bar, that would just mean average of delta f, or average rate of change. Got to be careful, because I could argue that delta f bar means something different. Find all of your delta f values and then find the average, which would be different. So I will stick with this notation. And f of x final minus f of x initial over x final minus x initial. F of 1 0. F of negative 1
Negative 2.
You said
2.
negative 2? Positive 2, right? 1 minus negative 1. I hope it's not 0. That'd be a problem. And then negative 2 over 2. Average rate of change here is negative 1. And one more for average rate of change. F of x final. What's x final?
5.
Minus f of x initial over x final minus x initial. F of 5.
18.
f of 2,
3.
1.
I agree, 3. All over 3. What's 18 minus 3?
15.
15 over 3.
5.
Average rate of change is 5. So keep in mind what this is saying for this particular problem. It says on average, for every increase in x by 1, so every time x increases by 1, on average f will increase by 5. Right, so on average, you go to the right 1, you're going to go up 5. That's what average rate of change is saying.
So it's kind of just telling you the slope of the line.
That's exactly what it is. It's slope of the secant line between the 2 points. Now, obviously, to really get a good rate of idea of what the true rate of change is, you want that interval to be really small. Right? In this case, 2 to 5 is a pretty large interval, so it's not going to give you a real good idea of what it's doing at 2. Right? So, for instance, if I go from 2 to 2.1, it's not really giving you a good idea of what's happening. But that, again, is touched on in calculus, because that's the whole idea behind what a derivative is. Good, I do get to the graphing utilities. So I'm going to use graphing utility to find local extrema. Make sure I open up the right one. I did, okay. Remember, the software that I'm using is the TI Inspire CX and CX2.
You can just use decimals, right?
Yeah, except you can't do that on test. You have to use your calculator for in-class exams. So TI 83 or 84,
That can do this.
that'd be able to do it. The method might be a little different than what I'm showing off, is what I'm trying to get at. Right, your buttons may be different. If you have the TI Inspire CX, right, so again, be careful with the CX because there's 2 versions of the CX. There's the CX, either 1 or 2, and then there's also a CX CAS. You cannot use the CAS. That's computer algebra system that has symbolic manipulation. You cannot use that for pre-calc. You can only use the normal CS. Right, so you come on, this is your home screen. Right, the cool thing about the CX, the Inspire, is that you can actually save documents right on it. Right, so you can create a new document to save. Just, I can tell just by looking at that, that's the CAS version.
You got the wrong one.
The non-CAS has the white background on the keyboard, not the black. So if you look up at the top right corner, there's a CAS after the CX2, right? Yeah, that's the wrong version. Are you moving on to calculus, calc 2, calc 3, all that?
Yeah.
Keep that calculated, because depending on where you take and who you have, you'll be able to use that. Like if you have me for calc, I let you use that. And if you're engineering or any kind of science, you'll be able to use that as well. So it may be worth just hold on to that. And then maybe find like a 83 or something that's like $20 or something and use that version. Or borrow a graphing calculator from a friend or family member.
I don't know. Bought one last semester.
Yeah, so on a test, you won't be able to use that. For the course purpose, you can use it. It's fine. If you get the non-CAS version, it's going to be the exact same thing. The method's going to be exactly the same. For the most part, I just use Scratchpad. So you can either, the center here acts like a mouse pad, or you can just hit A. That loads up the calculator scratch pad. B would bring up the graph. If you're already on this screen, again, you can use mouse pad to come up over here and click this, or Control 0. Now just type in the function, which was x cubed. All right, so x caret 3. Now be careful. The cursor is still in the exponent. Observe. That is not what we want. So when you do a power that way, you can't hit tab because it freaking does that. You have to hit. Let's redo that. Let's uncheck that for now. All right, so I'm still in there. You have to hit this arrow button here. Just click that. Now you're out of the power. Then it was minus 3x plus 2. Then you can either hit tab or enter. No, enter doesn't do anything apparently. Oh, because I unchecked it. So I'm gonna recheck it. Right, enter or tab will bring you down to the next one. I don't care about that. If I hit enter again, it should bring me out of it. And so there's your graph. Again, notice this is probably the only thing I hate about this calculator is the y scaling and the x scaling are not the same.
Why wouldn't it just go to 10?
Because the scaling is not the same, so it's not going to give you a. It's actually going to. I think it squishes it, which irritates me. This is how they scale it. So this would be the same scale as a normal negative 10 to 10 all the way around. I hate it, but it is what it is, and it doesn't matter for our purposes. Now I'm going to go menu, 6, analyze graph. Right, so again, you can either scroll over to it or just hit 6. And then you have two options. You have a lot of options, but the two we're looking at, minimum, maximum. So I'm going to hit 2. We're going to find the minimum first. You're going to have to choose a lower bound and an upper bound. Right, we're looking for local, right? Clearly, local looks like it's going to be at x equals 1. So I'm going to scroll over, right about there, for my lower bound. Enter. Yes. And scroll it over, maybe right about there. Enter. There's your minimum. 1, 0.
How do I do that on mine?
It's a similar process.
I got it, the graph.
Yeah, it's a similar process. I think you have to hit the graph button or the tools button. I have to take a look at it because I don't quite remember. And then I'm going to do the same thing for the maximum. And there's your max. Screenshot it. And then what I'll do is I'll just paste it on there. There are 3 other questions that are the same thing, just different functions. Use a graphing utility. So do that on your own. using your calculator. Are you comfortable with it? That's how you would use technology to find the maximum end. So at this point, your second homework is also up. That'll be due next week. Don't forget, your first homework is due Monday. Continue working on the first project. Monday, I think we do function algebra. So we look at operations on functions, addition, subtraction, multiplication, division, things like that. Have a good weekend.